Welcome to Penrose Learning, where we make understanding easy.
Today I will guide you to build a basic Lidar scanner step by step. You will assemble a rotating sensor, a laser module, and a microcontroller board. The design uses a 650 nm laser, a time-of-flight sensor, and a 360-degree servo. Plan for a 5V power supply, 1A current capacity, and stable mounting. You will collect scans at up to 10 HC and store points in CSV format. Safety matters. Wear laser goggles rated for 650 nm and keep beam enclosed. Gather these parts before you start: microcontroller, stepper or 360-degree servo, and encoder. Install the laser module with a collimating lens and a 3.5 mm aperture for beam shaping. Mount the sensor on a rotating platform and attach the encoder for angle feedback. Wire the sensor and laser to the microcontroller using I2C and a PWM output. Write firmware to trigger measurements, read angles, and timestamp each distance reading. Save points as X, Y, Z using simple polar conversion and log to SD card or Wi-Fi. Begin with static tests to verify distance accuracy at 0, 5M, 1M, and 5M. Calibrate angle offset using the encoder and a known 360-degree reference mark. Filter raw data with a median filter and remove outliers beyond 3 sigma. Convert polar coordinates to Cartesian using x equals r cos theta, y equals r sin theta. Visualize point clouds in a viewer and check for holes every 5 degrees. Maintain the scanner by cleaning optics and checking laser output monthly. Use ground truth measurements to compute RMS error and
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.